Swayam Prabha. Digital India. Educated India.
Namaskar. So, today in this session we will discuss about the source transformation. What do you mean by source transformation? When we discuss the series parallel combination of the circuit in the previous lectures, and we also discussed the star delta transformation, we came to know that with the help of these two techniques we can solve the circuit very easily. In case of series parallel combination, we discussed that when the elements are in series or in parallel, how voltage division and current division works. Similarly, in the lecture on star delta transformation, we discussed that if the circuit looks very complex and if you can figure out that there is a pattern for either star or delta, then you can try star delta transformation and make the circuit simpler. So, in these two ways we discussed in our previous lectures that how you can simplify the circuits. So, in the same way today we will discuss how source transformation can help you to resolve the circuit and solve the circuit with the help of this particular technique. So, in this source transformation what we will do, this would be considered as a tool which is the concept of equivalence. What do you mean by equivalence? Let us first understand what is equivalent circuit. So, equivalent circuit is the one whose voltage current characteristics are identical with the original circuit. So, that means that if you have VI characteristic identical for two circuits, you can say that both one is equivalent circuit of the second one, and this property of the circuit is called equivalence. Now, what is the source transformation? Source transformation is the process of replacing a voltage source which is having one resistor in series by a current source which has one resistor in parallel, or that can be vice versa, means one voltage source in series with one resistor can be replaced by one current source parallel with the resistor, or current source in parallel with the resistor can be replaced by voltage source in series with the resistor. So, how we will do it? Let us understand. In case of node voltage or mesh current method, the equations we were obtaining were simply with the help of circuit inspection. So, we were seeing the circuit and identifying basically the assigning the mesh currents in the various meshes and then trying to find out what would be the value of mesh current. Similarly, in node voltage we were assigning voltage at the node, and using Kirchhoff voltage and current law we were trying to identify the node voltage value. So, this was basically we were doing with the help of either independent current or independent voltage source, or we were also discussed that the same technique can be used for dependent current as well as dependent voltage sources. Now, this we have already discussed. Suppose if we want to expedite our circuit analysis, we can add the voltage transformation also, so that we can speed up our circuit analysis process. So, what we will do? We will substitute a voltage source in series with resistor for current source in parallel with resistor, or vice versa. So, if you see the figure, between terminal A and B you have one series resistance R and one voltage source Vs is connected. Now, the source transformation technique says that if you have voltage current relationship at node A and B same for both of the circuits, it means that this can be represented as a equivalent circuit using one current source in parallel with resistance R. Now, next question would be how we will find out the value of Vs in terms of Is or Is in terms of Vs, or what will happen to these two resistances, whether both will remain same or those are going to change. So, in this particular technique we will try to understand that when we will do the source transformation, how the value of the various sources, that may be from voltage source to current source, then we have to find out the value of current source, and if it is from currents to voltage, then we have to find out the equivalent value of voltage source, and then what would be the value of resistances connected in series or parallel. Now, we know that it is very easy to show that these are equivalent. What we will do? We will first turn off the source and we will find the equivalent resistance across the terminal A B. So, if you see this circuit, switching off the source means what? Switching off the source means if you have a voltage source, you will simply make it as a short circuit, and if you have a current source, you will make it as a open circuit. So, this will be opened if you are having the voltage source, or short circuit if you are having the if you are having current source, it will be open circuited. If you are current source, it will be if you are having voltage source, it will be short circuited. So, if you see in this case and you are trying to find out equivalent resistance across A B, when voltage source is short circuited, you will see equivalent resistance is R. Similarly, in case of current source, if you make current source open circuit, means it is disconnected from the circuit, then again the equivalent resistance would be R. So, what will happen when we analyze both of the circuits, we will see that equivalent resistance across the terminal A B will remain same, that is R. So, that would be in both of the cases. Now, if you are making short circuiting the terminal A and B, what would be the value of short circuit current flowing from A to B? Now, let us see this circuit once again. When the circuit is same as it was previous, the thing which you have to do now is that you have to short circuit A and B, and your objective is to find out the value of this current, short circuit current. So, suppose if it is ISC, so what would be the value of ISC? ISC would be simply Vs by R. Now, in this case, if you are short circuiting A and B, what will happen? This will be in that case neglected. So, the current flowing short circuit current flowing from A to B would be C is equal to the Is. So, here we will represent with the same circuit like Is given in small form. So, now as we discussed that when we are creating the equivalent circuit, its properties should remain same. That means that short circuit current should be same in both of the cases. So, what we get from here? We get from here is nothing but Vs by R equal to Is. So, this will give you the idea that when you want to do the source transformation, how the current source would be related to voltage source, right. So, this we got with the help of circuit, and now we found that this is the relationship between voltage and current sources when we are doing the source transformation. So, what we got the voltage relationship as well as resistance relationship. For resistance relationship, we tried to find out the equivalent resistance across the terminals, and for the current and voltage source relationship, we just saw when we short circuit A and B, what would be the value of the current flowing through the short circuited terminal. Now, instead of short circuit, suppose if you are asked, if you are verifying the same concept with the open circuit, because short circuit and open circuit are both the characteristic of the circuit. So, in case of open circuit, what will happen? What would be the open circuit voltage across A and B? Open circuit voltage across A and B would be Vs. Similarly, in this case, what would be the open circuit voltage? Open circuit voltage would be Is into R. Now, as per property, if you see that both of the circuits are equivalent, your VOC for first circuit or VOC for second circuit should be equal. So, what you get? You get Vs is nothing but Is into R. So, this is the same thing which you got in previous case. What we got in previous case? Vs by R is equal to Is. So, you can cross verify that whether it is short circuit characteristic or open circuit characteristic, the circuit is equivalent because it is giving the same output. So, now we have stabilized the relationship between voltage source and current source in both of the equivalent circuit. So, we can summarize that the relationship between the voltage sources and current sources would be Vs is equal to Is into R, or Is is equal to Vs by R when we have to go for source transformation. Now, source transformation can also be applied to dependent sources, that may be the dependent voltage source or dependent current source, but this we have to handle carefully because the dependency of the various sources from the any voltage or current variable through some other element. So, because of this dependency, we have to be very careful that how you will handle the source transformation. So, when you do source transformation and you see dependency with the resistance flow, that particular resistance we cannot consider for the source transformation. So, that is something which you have to be very careful. Now, let us see the circuit below. As we saw in the previous case, in this case also you can stabilize the relationship that if voltage source is in series with resistance R, so it can be represented equally as current source in parallel with resistance R. So, in this case voltage source would be dependent voltage source, similarly current source will also be the dependent current source, and the relationship with these two should be stabilized in such a way that the dependency of these sources is intact. So, like in a star delta transformation, the source transformation does not affect the remaining part of the circuit. So, you will apply them for one particular segment of the circuit, but this will not impact rest of the circuit. So, when applicable, the source transformation is a powerful tool that allows circuit manipulation to ease the circuit analysis. So, wherever you see the possibility of source transformation, you apply them and make the circuit simpler. Now, what you have to keep in mind? You have to keep these 2 points in mind while dealing with the source transformation. What is that? First is that arrow of the current source is directed towards the positive terminal of the voltage source. Like this is the positive terminal of the voltage source. So, current source should point towards the positive terminal of the voltage source. Now, source transformation is not applicable when R is equal to 0 in case of the voltage source. So, if you make R is equal to 0, this will become an ideal So let us see this. If you make R is equal to 0, then this will become ideal voltage source, and if you make R is equal to infinity, this will become ideal current source. So ideal voltage source and ideal current source cannot be transformed from voltage to current or current to voltage. So this also we have to keep in mind when we are doing the voltage or current source transformation. Why? Because when you have ideal current source, you cannot replace with any finite voltage source, right. So that is why it is not applicable when the voltage and current sources are ideal. Now let us take one example so that you can understand the source transformation concept. Now suppose if the circuit is given like this and you are asked to find the voltage V naught which is across 8 ohm. How you will solve? Now let us see